This is Math 221, and this is a short video on interpreting the graph of the first derivative. And what does that tell us about f of x if we're given that first derivative function f prime of x, or if we're given the graph of that function. So here's this curve here is f prime of x. So on my horizontal axis are my inputs x, and my vertical axis is f prime of x. So the first thing I like to do is locate where the derivative, the first derivative, is equal to 0. So here, when x equals 1, the first derivative is 0. And when x equals 3, right here, the first derivative is equal to 0. So if I write it in function notation, f prime of 1 equals 0, that tells me that I have a critical point. That tells me that f of x is flat there. My second point is f prime of 3 is equal to 0. That's another critical point. That tells me that f of x is flat. So we know that it could either look like this, if I have a flat point, this, or I could have a situation, right, where I'm flat for a second, but I don't change whether f of x is increasing or decreasing. I want to see which one of these four scenarios do I have. So I want to test those critical points, but instead of testing them, with my number line method that I use, I'm using the graph to tell me what's going on. So if I look here, if that kept going both ways, so when x is less than 1, my derivatives are positive because they're above the x-axis. So this whole stretch here, f prime of x, is positive. That is telling me that f of x is increasing. At this point here, this critical point, f prime of 1 is equal to 0. That's telling me that f of x is flat. This next stretch, okay, my derivative is above the x-axis. So f prime of x is positive. That's telling me that f of x is increasing. So notice at this critical point, I'm increasing, flat, and I'm increasing again. So that tells me that x equals 1 is not a max or a min. This problem is going to ask me for local max or local min. At this critical point, I don't change. I'm increasing, I'm flat, and then I'm increasing again. So that's not a max or min. So let's look at the rest of this graphs here. So f of x is increasing here. Here's my other critical point, right? F prime of 3 equals 0, so that tells me f of x is flat there. If I continue on, the derivative is below the x-axis here. So my first derivative, f prime of x, is negative. That's telling me that f of x is decreasing. So when I look at this critical point, 3, 0, I know that I go from increasing to flat to decreasing. So that's telling me that x equals 3 goes from increasing to flat to decreasing. It tells me that x equals 3 is my local minimum. I don't have any local maximum, does not exist. If I want to write these intervals for increasing, decreasing, f of x is increasing from negative infinity all the way to 1. At the critical point, it's neither increasing or decreasing because it's flat for a second. The derivative is 0. When f of x is positive, it tells me, when f prime of x is positive, it tells me that f of x is increasing, flat for a second. Then the derivative is positive again from 1 to 3. F prime of x is positive from x equals 1 to x equals 3. Again, that tells me that f of x is increasing. But because I don't change from increasing to decreasing or decreasing to increasing, tells me that f of 1 is not, or x equals 1 is not a max or min. All right, so then f prime of x is positive from x equals 1 to x equals 3. That tells me f of x is increasing. At this critical point here, I'm neither increasing or decreasing, but then from x equals 3 to x equals infinity, I'm below the x-axis. So f prime is negative. That tells me that f of x is decreasing, That's telling me that that x equals 3 is a maximum because I changed from increasing to flat to decreasing.